Greetings of the day. I am Dr. Ronika Panmar and I welcome you all in today's lecture on application of multiplexers and demultiplexers. These electronic devices might sound complex, but they are fundamental components in modern technology with a wide range of applications. Today, we will explore some of the most exciting and practical uses of multiplexers and demultiplexers in various fields. These are used in wide variety of applications, but this class particularly will discuss about the practical applications. So, the outline for today's class are here. So, first we will discuss about the multiplexer and demultiplexer. In multiplexers, we will see the multiplexer pin diagram, using of 4:1 multiplexer, 4:1 multiplexer circuit diagram with the examples of multiplexer and their applications. Further, we will move ahead towards demultiplexer and we will discuss its pin diagram, followed by the understanding of 1:4 demultiplexer. We will see the examples for demultiplexer followed by its applications. So, let us start our lecture with multiplexers and demultiplexers. A multiplexer is a circuit that accepts many input but give only one output, as we have discussed it in the previous lecture. Similarly, for the demultiplexer, a demultiplexer function exactly in reverse of the multiplexer. That is, a demultiplexer accepts only one input and may give many outputs. Generally, multiplexers and demultiplexers are used together because of the communication systems, as they are bidirectional. So, we require to multiplex the data and then transmit it, then receive it and then demultiplex it. So, they are generally used in pairs or they are used together, because a communication system completes a system by transmitting the data and then by receiving the data. So, a multiplexer means many into one. A multiplexer is a circuit used to select and route any one of the several inputs to the signal output. In a multiplexer, one of the input is represented at the output. A simple example for a non-electronic circuit of a multiplexer is a single pole multi-position switch. Multi-position switch are widely used in electronic circuits. However, they operate at high speed, require the multiplexer to be automatically selected. A mechanical switch cannot perform this task satisfactory manner. Therefore, multiplexer used to perform high speed switching are constructed of electronic component. Multiplexer handle two type of data, that is analog and digital. For analog application, multiplexers are built of relays and transistor switches. For digital applications, they are built of standard logic gates. The multiplexer used for digital application, also called digital multiplexer, is a circuit with many inputs but only one output. By applying control signals, we can steer any input to the output. Few types of multiplexers are 2:1, 4:1, 8:1 and 16:1. So, let us move ahead and discuss the pin diagram of the multiplexer. So, figure 1 shows a general idea of a multiplexer with n input signals and m control signals with one output signal. So, this is the representation of the multiplexer with n input signals and one output signals, and the selection is done by the control lines, and let us say they are m in numbers. So, with the help of these control lines, the data which is to be represented from the input to the output is selected. So, this control line selects the input that is to be replicated at the output line. So, the 4 to 1 multiplexer has 4 input bit, 2 control bit and 1 output bit. 4 input bits are D0, D1, D2 and D3. There is only one output Y. The output depends on the value of A and B, which are the control lines. The control input determines which of the input data is transmitted to the output. For instance, as shown in figure 2, when AB is equals to 0, the upper AND gate enables while all other AND gates are disabled. Therefore, data bit D0 is transmitted to the output giving Y is equals to D0. If the control input is changed to AB is equals to 1, 1, all gates are disabled except the bottom AND gate. In this case, D3 is transmitted to Y and Y is equals to D3. So, figure 2 shows the logic diagram for 4 input to 1 output multiplexer. This is the circuit diagram which we have been discussing. An example of 4 to 1 multiplexer is IC 74153, in which the output is same as the input. Another example of 4 to 1 multiplexer is 45352, in which the output is the complement of the input. The example for 16 to 1 line multiplexer is IC 74150. So, we can have the output to be replicated as same as the input, and we can take the complement of the input also. If let us say input is 1 and the IC is complementing the output, then we will get output 0, because the input 1 was transmitted to the output and at the output it is being complemented. So, 1 converts to 0. Same will vice versa will be the case for 0. So, let us discuss the applications of multiplexer. Multiplexers are used in various fields where multiple data need to be transmitted using a single line. Following are some of the examples of multiplexers. So, the first example is telecommunications network. Multiplexers are backbone of telecommunication network. They combine multiple voice and data signal into single transmission line, optimizing the bandwidth usage and enabling efficient data transmission over long distance. The cable TV. In cable TV or cable television system, multiplexer is essential for bundling numerous channels into a single cable. This technology enables subscriber to access a wide range of programming options from news to entertainment. Data center networking. Data centers rely on MUX technology to manage and route data traffic with server farms. Multiplexer device helps balance the load, ensuring efficient data processing and transmission. Fiber optic communication. High-speed fiber optic networks use MUX to combine multiple data streams into single optical fiber. This process minimizes the utilization of optical infrastructure and enhances data transmission efficiently. Digital broadcasting is a key component of digital broadcasting, including cable and satellite television. It has audio and video signal, ensuring efficient transmission of digital content to viewers' home. Time division multiplexing, it is also known as TDM. TDM facilitates by multiplexer, involves dividing a communication channel into time slots. Each slot is allocated to different user, allowing multiple users to share same channel without interface. The video over IP, known as VoIP, it is a telephony application. In video over IP system, multiplexer is used to packet and route voice data over internet. This technology enables modern telephony system, including voice and video calls over IP network. The WhatsApp calls which we use today or various video calls that we use today uses this multiplexing system. Wireless communication system. Wireless networks rely on multiplexer to multiplex data streams, supporting mobile phone connections, Wi-Fi networks and other wireless communication technologies. Data acquisition system. The multiplexer plays a crucial role in data acquisition system used in industrial and scientific application. It selects data from various sensors, enabling the simultaneous collection of data from multiple sources. Satellite communication. In satellite communication, multiplexer integrates data of various sources of transmissions via satellite. This technology contributes to global connectivity and facilitates communication in remote areas. Environmental monitoring. MUX is employed in environmental monitoring systems to route data from various sensors. It aids in weather forecasting, pollution control and climate research by collecting data from multiple sources. Medical devices. MUX are used in medical devices to manage signal from various sensors, facilitating diagnostics and patient monitoring in healthcare settings. It ensures seamless integration of data from different monitoring devices. It is used in industrial automation. MUX is vital for industrial automation as it routes signal and instruction to automate system. It enhances production process, improves efficiency and reduces human intervention. It is used in security and surveillance. MUX routes video fed for surveillance camera to monitors and recording devices. It is a fundamental component of security system, enhancing security in residential, commercial and public spaces. It is used in aircraft also. They are also used in digital cameras. They are used in smart grids as well. They are used in GPS and navigations also. So these application demonstrates the versatility and significance of multiplexers in various industries and technologies, where they play a crucial role in optimizing data transmission, resource allocation and signal management. Let's move ahead towards demultiplexers. Demultiplexers means one to many. A demultiplexer is a circuit with one input and many output. By applying control signal, we can steer any input to the output. The core function of the demultiplexer is to route from one of its data input to the output line. This selection is determined by the binary state of control inputs. Each combination of the control input corresponds to a specific data at the output. Few types of demultiplexers are 1:2, 1:4, 1:8 and 1:16 demultiplexer. Following figure illustrate the general idea of a demultiplexer with one input signal, m control signals and n output signals. So here we can see the diagram for a demultiplexer. Here it has one input signal, m number of control lines and n number of output lines. The 1:4 demultiplexer has one input bit, two control bit and 4 output bit. An example for a 1:4 demultiplexer IC 74155. The 1:4 demultiplexer is shown in the figure 4. So, this circuit is the example for a demultiplexer. Here we can see we have one input line and 4 output lines along with two control signals. Input bit is labeled as data D. The data bit is transmitted to the data bit of the output line. This depends upon the value of A and B, the control inputs. When AB is equals to 0, 1, the upper second AND gate is enabled while the another AND gate is disabled. Therefore, only one data bit D is transmitted to the output, giving Y1 data. If D is low, Y1 is low. If D is high, Y1 is high. The value of Y1 depends upon the value of D. All over the outputs are now in low state. If the control input is changed to AB is equals to 1, 0, all the gates are disabled except the third AND gate from the top. Then D is transmitted only to Y2 output and Y2 is equals to data. Similarly, we get other outputs also. The example for 1:16 bit demultiplexer IC is IC 74154. It has one input bit, 4 control bits and 16 output bits. The application for demultiplexers are here. Demultiplexers is used to connect a single source to multiple destinations. The main application area of a demultiplexer is communication system where multiplexers are used. Most of the communication systems are bidirectional as discussed. They function in both the ways as transmitters and receivers. Hence, most of the applications, multiplexers and demultiplexers work in synchronous. Demultiplexers are also used in reconstruction of parallel data and ALU circuits. They are widely used in communication system. Communication system uses multiplexer to carry multiple data like audio, video and other form of data using single line of transmission. This process makes the transmission easier. The demultiplexer receives the output signal from the multiplexer and convert them back to the original form of data at the receiving end. The multiplexer and demultiplexer work together to carry out the process of transmission and reception of data in communication system. Digital broadcasting. In digital broadcasting, demultiplexer is employed to extract specific audio and video streams from the multiplexed signal. This technology ensures that viewers receive their selected channels and service without interference of their other broadcast. The demultiplexer plays a crucial role in delivering high quality content to television and digital devices. In cable TV systems uses demultiplexers to separate and deliver individual channel to the subscriber. This allows viewers to access their preferred channel within the cable TV lineup. It is an integral part of cable distribution, ensuring each household service content they subscribe. Fiber optic communication. High-speed fiber optic network uses demultiplexer to separate incoming optical signal into distinct data streams. This process is vital for efficient data transmission and reception. Demultiplexer ensures that data is properly routed and demodulated from the optical signals, enabling fast and reliable communication. Wireless communication system. Demultiplexer is used in wireless networks to segregate data streams, facilitating distribution of data to individual user or device within the network. This technology is crucial in modern wireless communication where numerous devices share the same frequency spectrum. Satellite communication. Demultiplexer is essential in satellite communication to separate signals from different sources. It allows for the reception of specific channel and service via a satellite links. This technology is used in television broadcasting, internet access, global positioning system, that's GPS, and other applications as well. They are used in arithmetical and logical unit. In a ALU circuit, the output of the ALU can be stored in multiple registers or storage unit with the help of a demultiplexer. The output of the ALU is fed as the data input of the demultiplexer. Each output of the demux is connected to multiple registers which can be stored in the registers. Data center networking. Data center relies on demultiplexer to distribute data packets to the appropriate server or destination within the network. This helps balance network traffic and optimize data processing. By efficiently sorting the directing data, demultiplexer contributes to the high performance and reliability of the data centers. Time division multiplexing, TDM. In TDM system, demux play a key role in dividing time slots and routing data to their respective destination. This ensures that multiple users can share a communication channel without interference. TDM is widely used in telephony where demux helps separate voice data from the various callers. Voice over IP. In the voice over IP telephony system utilizes demux to extract the voice data packets from the incoming network traffic. This allows for the proper routing and processing of the voice calls over IP network. Demux ensures that voice data is separated and delivered in real time, providing clear and uninterrupted calls. They are used in data acquisition system. Industry and specific data acquisition system employs DMUX to separate and process data from the various sensor and instrument. It ensures that data from various sources is correctly channeled for analysis and storage. It is vital for monitoring and controlling industrial process and scientific experiments. They are used in medical devices. The DMUX separates and processes the data from the sensors, monitors and diagnostic equipment. It ensures that the healthcare professional receives accurate and relevant patient information. DMUX is integral to devices like ECG, pulse oximeters and blood pressure monitors. They are used in environmental monitoring. They play a significant role in the environmental monitoring system by separating data from sensor measuring various environmental parameters. It aids in climate research, pollution control and weather forecasting. DMUX helps process data from instruments that monitor temperature, humidity, air quality and many more. They are used in industrial automation. In industrial automation, DMUX routes control signal to specific machinery and devices. It enhances automation process, improves efficiency and reduces human intervention. DMUX is used in manufacturing, robotics and process control systems. They are used in traffic management systems as well as they are used in security and surveillance. Surveillance system uses DMUX to extract video feeds from multiple cameras. It enables security personnel to monitor and record video from various locations simultaneously. DMUX supports security application in home, businesses and public spaces. They are used in aircrafts as well. In digital camera industry, the DMUX extract audio and video streams from the content distribution system. This technology ensures high quality movie playback in theaters. DMUX supports the digital projections of films and cinematic experiences. This ends our topic for the today. Today we have discussed the real-time application of these devices, the practical uses of these devices. One more, the demultiplexers are used as decoders as well. If we don't have a decoder IC, we can use a demultiplexer IC. So these are the applications which are used in the practical modern day society. So today we have discussed about the multiplexer and demultiplexer. We have refreshed our knowledge and then we have moved ahead and looked for the circuit diagram and examples of multiplexers and demultiplexers. Further, we have discussed about the demultiplexers where we have seen its circuit diagram and its application in real time for the benefit of the society. So this ends our discussion on multiplexers and demultiplexers. So in the previous lecture we have seen about the multiplexer, then we have discussed in detail about demultiplexer and today we have seen its application. So see you in the next class. Thank you for attending this lecture.